Hey class, in today's lesson we're going to talk about counting principles, which is found in section 9.6 part 3. We're going to use combinations to solve counting problems. So the number of combinations of n elements taken r at a time is this formula that you see below. So we will use this when we are dealing with combinations taken so many at a time. So in example 8, it says, in how many different ways can 3 letters be chosen from the letters A, B, C, D, and E? The order of the 3 letters is not important. So it was very important that they kind of told us that the order is not important, because then that lets us know that we are working with combinations. So with that being said, if we start our problem, there are 5 letters. So the number of elements is 5. And it says that they can be arranged. It says, in how many different ways can 3 of those 5 letters be arranged? So the R, or the amount taken per time, is 3. So if our formula will be the combination of 5 choosing 3 at a time, would be 5 factorial over 5 minus 3 factorial times 3 factorial. Okay, so 5 factorial we know is 5 times 4 times 3 times 2 times 1. 5 minus 3 is 2, and 2 factorial is just 2 times 1, and 3 factorial is 3 times 2 times 1. Okay, so with that being said, the 3, 2, 1 is going to cancel, and then 4 divided by 2 is 2. So our answer is 10 different ways. All right, let's look at example 9. It's our last one, by the way. So it says a standard poker hand consists of 5 cards dealt from a deck of 52. How many different poker hands are possible? So again, with this example, what we're going to do is we are going to say that the amount of elements is 52. There are 52 cards in a deck. But for a poker hand, we have to take 5 cards at a time. So to follow that formula, it would be the combination of 52 cards choosing 5 at a time. So that would be 52 factorial over 52 minus 5 factorial times 5 factorial. So 52 minus 5, by the way, is 47. So this would be 52 factorial over 47 factorial times 5 factorial. Really what I'm going to do is start listing 52 until I get to 47. So 52, 51, 51, 50, 49, 48, 47. And I'm going to put a factorial at the end of that last one. It looks really bad, but 47 factorial, I'm going to switch a color so you can see it, factorial over 47 factorial. And then 5 factorial is simple, right? That's 5 times 4 times 3 times 2 times 1. I'm doing that because I want 47 factorial and 47 factorial to cancel one another out. An easy one for this 5 can be 50. So 50 divided by 5 is 10. With this 4, I know 48 is divisible by 12, so by 4. So 48 divided by 4 is 12. I can divide that 12 by 3 and I'll get 4. And I can divide that 4 by 2 and get 2. So what I have left is multiplying 52 times 51 times 10 times 49 times 2. That is going to give me as a final answer 2,598,960. Now guys, if you come see me in class, I can show you the calculator version of this. There is a version to do this on your calculator using the probability function, but this is how you can do it by hand. If you guys have any questions, please be sure to come stop by and see me for tutoring.